Alright, welcome back to the Friday Open Studio design session. You'll realize that this live session is probably going to be a little shorter than the others, and that's because I was mostly through a live stream already. I was probably 90 minutes in, I had like 30 minutes left, and YouTube decided to crash the entire stream. The app glitched out and it didn't work anymore. So I had to delete the old stream and start again. So it's not going to be as long as the other ones. It's probably only going to be 30 minutes. I'm going to stop at 7:30. So, this is what happens when YouTube is incompetent and their app crashes. So you just lose a bunch of good learning and tutorials for this hobby, I guess. But I will catch you guys up really quickly on what happened so far in this week's stream. Remember last week we made the tail assembly here, right? We attached the pin, we attached this entire mechanism to the main shaft. You realize there are holes here, like a slot to move back and forth, right? There is a pin here, that slides forward to deploy the slat mechanism. So that's kind of where we left off, and it took several sessions to get to that point. But right now, in this week's stream, which will be truncated because YouTube is incompetent and crashed the stream that I already started that was over an hour long. We're just going to do a 30-minute stream really quick and continue where we left off. Hopefully you capture some of the design that went into this. Essentially, this is what we're going to make, right? We still have the left side here that's left to go. But this is the slat deployment mechanism right here that we're working on. We made this one in the stream that YouTube decided to crash, which pisses me off, to be honest, but it happens, technical difficulties. So we're gonna do our best with the left side slat and try and capture as much of that knowledge as possible. All right. Yeah, it really sucks because, when it crashes, it doesn't let you stop the stream at all. Like, you can't continue to stream, you can't stop the stream, it's just live there, and it's gonna go on forever. So it's just really dumb. Like, it's just a really dumb solution. But the only way to solve that is to delete the stream and then start anew, right? And hope nothing goes wrong again. So with that said, I'm starting this stream again. It's going to be shorter, it's going to be 30 minutes. We're going to finish off this side here, and actually it's at a stage right now where it's quite clear what the process, what the structure and design of this thing looks like. We start with this orange piece of steel wire that we already bent in previous sessions, and we tape the inner side here because there's a lot more surface area here, securely to this wooden popsicle stick, right? The thickness of the popsicle stick very closely matches the steel wire, and so when you tape this really securely on two ends here, then it acts as a bearing, a rotational bearing, right? It's a little bit sticky, but you can turn it. So I can demonstrate with the finished product here, right? This is what happens when you rotate it. Your slats deploy, right? And then they retract. So it's a very stable mechanism. And, the bearing itself, right, is just a tape piece that's been wrapped around this wooden spar, and the wooden spar acts as a spar, right? So it's very strong for the wings, and it's multiple functionality right here. It's serving as a bearing for the leading edge slats. So you attach the orange bit to the popsicle stick with pieces of tape here and here, right? Really tightly. You gotta make sure you really secure that piece so that it doesn't wobble around too much. And then what you do is you take your cardstock leading edge slat, you kind of shove it so that it's really tightly fit to this, right? And then you hold it in place, you open it back up, right? You hold it down in place, you tape this side, you tape the inboard and outboard, and then you apply a tape down the middle. And that tape down the middle is important because it prevents this leading edge slat from separating from the kind of metal skeleton that's underneath. So that's kind of what was explained in the last stream in a nutshell, right? We're trying to be super efficient here. We can't do this all over again. So we're gonna try and capture as much as possible here. All right, so we're at the stage where we need to seal the trailing edge, right? So it was done for this right side slat deployment mechanism. And if you were one of the 2 people watching that stream, you'll know that it's not a very straightforward process. So right when the last stream cut off, we got a piece of tape that was the length of this cutout, right? So this cutout is in between this point right here and this point right here. Right, so that's how long our tape needs to be. And then, so now we're about to cut this in half, right? So we don't need the full width. And this is, again, a standard piece of Scotch tape, which is 3/4 of an inch, which is 0.75 inches. I'm gonna take this, right? And really just, right, how did we do it last time? We put it on our thumb, right, like that, something like that, and then, well, we put it on our finger and just slide it through, right, slide it through this little gap in between, and yeah, and so we can pull from the other side, make sure it's relatively centered. Okay, so I can see this piece of tape is a little bit long. You'll notice that there is some buckling, right? There's some waviness there. So we'll have to remove this and trim down a little bit. All we really need is a little bit of tape being removed off the end there. Yeah, it really sucks that YouTube does that. You know, it's a technical bug, but it's still really annoying because we lose a lot of that valuable knowledge for others that want to recreate the same thing. But it is what it is, right? It's a fact of life. YouTube is incompetent, right? Their app crashes. Live streams don't always work out, so we're just gonna roll with it. It actually makes for a much more efficient stream, right? We did one part already. We're just finishing off the other. So I'm just trying to look for some positive in this whole situation here. All right, so that looks about right. And then, so now we can just apply pressure on one side, right? On the side that we put the tape through. And it might be a little difficult, right? So this is why we use something blunt to really, push down from the opposite side and make sure it's secure that way. Alright, you can see here it's pretty good integration. There's a little bit of an air bubble near the edge there, so I'm just going to really apply pressure there. All right, and now that that's done, we can rotate this a little bit, right? Just to get a little bit more space to work with. And we can close this leading edge slat off, right? And really secure the secure one side first, like that. And then fold the rest, right? As you fold, now you can apply the tape and secure it in place. Okay, that looks decent. And now that the trailing edge here is sealed up, right, just remove some of the bubbles and the wrinkles here. Honestly, like sometimes I use this as like a scapegoat excuse, but it really does. These little imperfections, they add a little bit more character to your end product. You know, it's a handmade thing, and this kind of shows that, right, it's not machine made to a certain spec or anything like that. So I find it a little bit charming, but ideally we wouldn't have those problems, but we're using office supplies here. So take it as you will. Right, and then so we now have to seal up the outer edge here. I mean, like the inner edge too, but it's just a little bit more complicated. I don't think we have a big enough slice of tape here for that, but we can try. It might take multiple pieces in this instance to secure it. Right, so you have this piece of tape just on there, and then it's going to wrap around, right? And then really tightly wrap around there, like that. Looks pretty good. And we're just going to close off the trailing edge on the outboard here. Right, something like that. And you just secure it on one side. Wrap it around, right, like that, and then just close it all off. It's a very tight integration right there. And then, you know, you can always clean off the excess. Like that. Would you look at that? That's a leading edge slat right there. So that's kind of how we did the other section here. A little bit more about the last stream that was unfortunately canceled. We also sized the spars and matched the geometries and cut them with scissors, which isn't the best way to go, but it's better than nothing, I guess. So we did that in the last stream as well. But now that we only have like 15-20 minutes left, maybe 30 minutes, I don't know if I'll go much longer because it's already been almost an hour and a half. But it's gonna be a shorter stream today. So now we're able to finally integrate everything together, all the moving parts, right? This is the moment we've been waiting for. It only took several weeks, but we're here. So let's get on with it. Okay, so the first thing is we'll probably need to align this straw first. We need like the straw to be anchored in place, right? And this hinge to be anchored in place. It's really the leading edge slats go on last, right? This is the important bit right here, because that's the tail surface. It's gonna enable us to pitch up, right? Both surfaces are synchronized so that it pitches the plane up. Leading edge slats down, tail pointing down, so you push your tail down, which pulls your nose up. Okay, so that's that. Now I've been thinking about this rear hinge right here for a long time, and I think we're gonna go ahead and use brass fasteners here. So probably gonna need 4 in this entire build, at least for the top half. I haven't decided for the bottom half if I wanted to do like a landing gear or something, because I feel like that would take this project to the next level, but we also need to make it light enough so that it'll actually fly, because otherwise it's kind of redundant, but or kind of purposeless, So I've been thinking about this, and I think we're going to attach it like it was really dumb of me to cut this section out. I really should have just left it in place and then cut it out after we did our thing. But this is kind of a finicky situation here. If this wasn't so circular, I would place this right there and it would fit and everything would be perfect. But it's not the case, right? It's a little bit too big. I'm not sure if I can actually trim this off. And even if I could, I don't know that would be the best solution. Right, so in the past, what we did was really wrap this brass fastener around a orange piece like that, around a wire, and then it acted, you puncture the material underneath, but then you can secure it in place and it'll be a secure fulcrum. But we're not able to do that here because there just isn't the material available to do that kind of a build. So I've been thinking about ways to get around that, and so far my, I guess, best attempt is to actually still use that, but go in from the back like so, right? You clip it in place, and let me just get rid of the slat mechanisms for a sec, and then you just kind of pin it in place like that. But I'm not sure how stable this is gonna be. This is like not very secure. We can do a dry fit right now to see if it works. But I have serious doubts about this working. Just move this surface to the top here for a sec. There we go. Right, so the only issues with this design, this configuration, is that shit. All right, open this up a little bit. Okay, so this is going to pinch around here, and right, it's gonna be a pretty tight fit, first of all, and second of all, this is like not secure at all. Right, it would be ideal if it were normal fit perpendicular to the surface, but another option is to use popsicle sticks, which I think might be the more elegant solution to all of this, but it'll take up more space and weight. Is to like just truncate off the end here and do the same thing that we did for this leading edge slat. Just tape it really, really securely to this and hope that it doesn't fall apart, which honestly isn't the best. I feel like, you know, because it can disassemble itself. For these main control surfaces that bear a lot of force when it crashes, I feel like it would be better to use this kind of a hinge. But I haven't tested this out yet, so I'm not sure. Yeah, it would be ideal to use these brass fasteners, but given our current situation, I'm not sure that that's a feasible thing. We can also fill in this gap. That's the other option. We fill in this gap, which would be kind of dumb, to be honest, but let's say we do that. It'll be a pretty reinforced area. It'll be pretty heavy, but we can get this thing to maybe work. So, question is, do we want to fill this in? I'm not sure. Or straight up use one of these? No. For the main surface, which has a lot of degree of motion, I don't think that's the appropriate solution here. So this is where you spend a lot of time thinking about trade-offs, right? So I would like to use these brass fasteners, but to do so, we would have to fill in this area. Or alternatively, we could puncture this base, right? Have a very thin base, and then wrap. So it'll be a very close incision to the edge here, which honestly might be a little bit weak. So I'm not sure if that's the best way to do this. We're kind of in a pickle here. We cut ourselves into a pickle. Really shouldn't have cut this section out, but on the diagram it was the engine, so I don't know how they did it on the real thing. It looks like there's not a lot of space to do it, but all right. I'm just thinking real quick. I guess we could do it like that, but then it would be pretty close to the edges as well. Something that wraps around this, maybe? Nah, that's gonna be kind of weird. maybe cardstock wrapping around this area right here, right, and a popsicle stick with tape here, and then cardstock, a sliver of cardstock wrapping around as reinforcement. That, I don't know if that'll do the trick. That's still quite questionable. And also cardstock wears down over time. So let's see, what about doing it like this, right? So the rod ends up being in the middle here of that little hole. And we can even rotate this, right? And have it there. It won't be a great hinge, so I don't know, I'm just trying to think this through. You can do it like that, maybe. Will that work? Just see for a second. Well, the only problem with that is that the anchor isn't a mechanically sound anchor, right? It still shifts, and we're literally just relying on tape so that it doesn't move. That's why the original method was so much better. Just puncture the material. So it looks like filling it in might be the best option, to be honest, which is surprising. All right. Okay, so to do that, we're gonna need some cardboard. I'll be right back. All right, so I got some more cardboard material. All right, so, oh God, this is what happens when you get too trigger happy and go forward with certain decisions. And cut out this exact shape. I don't think that would work too well. We can cut out an overlap rectangle. I don't really need it that big though. We only really need this much. Let's see how that much is. Maybe like approximately 2 centimeters. All right, so let's cut a 2 centimeter by, is it 4 centimeter? 2 by 4 centimeter rectangle. So let's do it. All right, so that's gonna be 4. Right. Then we're gonna count on this being a right angle here. Right, 2. Right. There we go. 4. And then 2 again. This, just cut it all the way through. good. All right, take the scraps, move it out of the way. As for today, we're gonna finish integrating everything. I know we're at the 30-minute mark, but we gotta compensate a little bit for the fact that the stream was interrupted by YouTube's incompetence. So we're gonna continue. To make things smooth, I feel like we should tape this on the bottom right here. So we're gonna draw a center line down the middle. Yeah, I really want to finish this mechanical assembly so we can get started on something new next time. So we're gonna try our best to finish this off today. All right, so we got 1 centimeter there, 1 centimeter here. Just going to draw a line like that. Okay, so now we have this line. We're gonna align it underneath here, right? Just like that. I wonder if a staple would work, to be honest. Huh, that's an interesting thought. Right, because if we put like a pin here, and then try and staple it right on this bit, it'll act like this, except I don't know. I've never tried it. Maybe not for this one. That would be a little experimental and risky because we might damage this part and not be able to get it back to its original shape. We already have a plan, so let's go forward with that. Right, so here it is. Right, you just line this up, and then make sure that we hold it in place. Apply a piece of tape across here. Honestly, this is a correction because I did not see this error coming into this. We need a solid, secure location to really tape the mechanism hinge in place. And the only way to do that, I'm gonna move this tape a little bit. The only way to do that is to have the actual material here. Which is what we're doing. We are supplementing this hole that we accidentally cut without thinking with material. So this is a mistake, but we are fixing it. Bit of tape. Right, secure that. Secure that. Mistakes happen. We're all human. So, all right. Now we can put this brass fastener in place. So the way we want to do this is I want to mark out exactly where. So that's going to be the outer edge there. So I'm trying to get it here. This hole right here forward. gonna try and replicate the same thing on this side. Actually, it would be better to use the actual part because the left and right sides might not be exactly the same. It's an unfortunate thing, but it is what it is. Was that one? This one. Now this one. You want to like match up the parts that you're gonna use for each side, and not assume that everything is the same, because these parts, they're not made with the highest attention to detail. These have a lot of variance in their fit. There we go. Right there. Then right there. All right, so we marked out the 4 locations where we're going to puncture the material below. And the best way to puncture is to use an X-Acto knife. So we're going to do that right now. All right, this is, you gotta be careful. You don't want to slice it too big. There we go. There we go. Looks decent. Looks good. Remember, this is going to be 2 layers right here. It's going to be extra stiff. So you want to be careful. Don't stab your finger, right? Be safe. Safety is first, always. There we go. All right, we did a puncture. All right, this is the part where it all comes together, right? This is the fun bit. This is what I live for, these moments. So, because this side is probably going to require a little bit more length, and these things are asymmetrical, we're going to align the longer end here with the deeper end here. So it's going to be a better fit. And we're just going to do that kind of ad hoc here for a sec. I'm just gonna try and insert this tail through, right? Insert this tail through like a dry fit, right? Like that. Okay, so that's all set. We're gonna do this side now. This side, let's see. Right, fits. We made our incisions and they both fit. Looks great. All right, we're just gonna take this out, and then put this down, right, in between, and then very precisely, or not, because we already marked out where to do it, so we don't have to be too careful here. Just slide it through all the way, right? Way to the bottom here. Good. And then do the same thing on this side. Right. Wrap the brass fastener around the axle. Just kind of push it down through this. And that's pretty much it. Now we can just adjust this a little bit. So now if you look from the back, you'll notice that this isn't a perfect fit like most things. Right, there's a little bit of a gap, so I'm just adjusting this out a little bit, you know, cutting into the material a little bit, but you want this to be secure. And then on the bottom side, you're just going to rotate both of these because there's not enough material in the back, so we're going to put both of them forward like that. Right, there's not enough support back here to split it, so kind of only can go forward with this. And that's just how it is in this particular design. For the Astra, it's slightly different, right? We're doing canards, so there's going to be a lot more room to do the split configuration rather than what we have here. But this is good. Still gets the job done. The main thing here is to have enough support material so that your hinge is stable. There we go. That's beautiful. All right. Sorry, I'm just gonna move this down a little bit. Right. So it looks like that. Right. You puncture it, you hold the rod in place, and then just kind of assemble it all. All right. So this is gonna be the neutral position, right? So we also need to secure the what we call it here, the straw, right? The straw itself needs to be secure as well. So make sure it's in the right location. Start taping it down. Okay. I'll just rotate this up for a quick sec. Just to get it out of the way. Now when you tape the main friction lock module down, you want to make sure you don't tape up the slots on the side, right? So I just taped slightly ahead of the slot. So just keep that in mind. You don't want to block that. Alright, looks pretty good. Okay, and then you just clean up the little excess strip of tape here. Good. All right, rotate that back down. You can also really secure the bottom side here. This isn't ideal, but we'll have to make do. Just attach both of these down with a single piece of tape. Keep it flat as possible. Can apply another piece of tape right behind this slot right here. We can't really do that for this location. I mean, I guess we could, it's just really impossible, right? So we're not gonna try and do that here. But in the front here, we can definitely apply a piece of tape right behind this slot, right? So right here, that's where we're gonna apply it. All right, so make sure it's really tight. Okay. Okay. And then we're going to do it to the front of this slot. Just for reinforcement. Just for peace of mind, you know. And then we're going to do it to the nose here as well. You really secure it down. Make sure nothing can really move too much. We might need some whatchamacallit, popsicle stick reinforcement here for the nose, because we don't want this plane to be damaged too quickly during flights, you know. That would suck if it just like completely totaled itself on the first flight. So we're gonna make it super durable, so that it'll last a long time. Just put the straps to the side here. And so we have our mechanism. Look at that. Look at that. We have the tail. Now, for the moment of truth, does it work? Well, that's a little stiff, but look at that. It moves. It freaking works, mate. That's pretty cool. With this new configuration too, with the slot cut out instead of the whole moving part. So that's pretty cool. All right, I'm pretty happy with this result. It took a long time to get here, but it's finally here. I think it's worth it. All right, but we're not quite done yet. Not done for today. We have a little bit more to go. I'm going to adjust the tolerances here later, but for now, we also need to make sure that the leading edge slat mechanism is in place and is properly installed. So that is going to be the last thing that we do today. We're going to really get all the moving parts working, and it's going to be freaking glorious when everything syncs up. And all the work that we put into this model so far will coalesce into one working symphony of moving parts, and that's just gonna be beautiful, man. It's just gonna be straight up beautiful. All right. So need to align. All right, let's do the right side first, because we did that side first anyway. So you gotta line up the spar with the leading edge, the wing, trailing edge of the leading edge slat. Something like that, right? Looks pretty good. I'm gonna have to grab a piece of tape the size of this. This time, it needs to be the full width, because we are assembling the whole thing together. So, I'm gonna grab this length right here, right? And we're going to, okay, this is really exciting. I'm so sorry if I like get a little too excited here, but I'm gonna put it through this slot, right? We're going to make sure it's halfway, maybe a little less on the top, because there is a thickness to account for, right? So less on this side because there's a thickness to account for. So a little bit over, right? Not too bad. Then just kind of put it down on this side, right? Your tape is through the slat, right? All right, this is really exciting. And then you line it up, wingtip in place, check, right? You want to make sure this rod is in front of the pin. So just a note there, right? Something like that. All right, we need to move this thing back a little bit. All right. Good. Good. All right. Now. Whew. Oh, all right. Yeah, my heart is beating. All right. Slide in place. All right. Wingtip in place. Everything is in place. Now we can just fold this over. Like that. And we've secured this spar to the wing through this convoluted mess that is going through the seam, right? Taping the top side, going through the seam, going to the bottom, and then securing it to the wing. So very complex, like I said, but completely necessary to get this thing to stay in place. Now, all we have to do is tape this in place, and that's going to take a long piece of tape, right? Full width, which is going to be approximately this much length, full width, and we're just going to put it in place down here, and it's going to be freaking secure, man. It's going to be freaking secure. All right, so we align this down, right? Just pinch this to the surface, make sure there are no bubbles, make sure the adhesive is on really tightly, and then you approach from the back side. All right, let me just lift off this piece that's stuck a little bit. All right, there we go. And then just do that. Just really secure it in place like that. All right, make sure the adhesive sticks on to the wing surface. Really well done there. Look at that. Look at that. Oh my god, this is beautiful. This is my second time making a leading edge slat. You know, the whole mechanism. So it's pretty amazing seeing it come together in a better form than my previous one, which is on the M1. This mechanism debuted on the M1, but it's been reinvented in this case for the M2, or not the M2, for the F16. I mean, for the wingtip here, we're just gonna do a quick trim operation, make sure that this is aligned properly. But otherwise, it's all good. that's really beautiful. All right, let's attach the other side. All right, so ended up being an hour anyways, this stream, but I feel like it's a lot more efficient than before. So there are plus sides to YouTube just booting me out. But that said, I'm still angry at YouTube for not being competent. Anyways, it's all exciting to see the whole thing come together. So, right, so we're gonna do the same thing again on the other side. I'm gonna grab a full width piece of tape. That's the length of this slot in between. Like that. We're gonna tape this down. Right, we're going to stick it through first. Slight adjustments so that, you know, again, you want this side to be a little bit shorter because you want to account for the depth or the thickness of the spar. They're really finicky. All right, looks pretty good. Maybe a little bit more here. Not sure. I don't want to introduce too many wrinkles. But I'm gonna line one side first, then pull the other side off. Shoot, no lead here. Ah, fuck. Alright, I just lifted off the other side. Alright, there we go. You know what? That's good. That's good. That's pretty close. Alright. There you go. Nice and secure. And then... oh god, this is really exciting. All right, we're finally doing this. It took only approximately 3 or 4 weeks, but we're here. Trailing edge of the slat aligned here. Spar with the leading edge. Right, looks good. And then just tape it. So there might be some slight tolerance issues, right? Some slight interference here, but we can always trim the fuselage to match the leading edge slat. So should be all set there. And then the final step is to secure this area right here. Right, you need approximately this much tape. All right, there we go. Ooh. Okay. Like that. I'm gonna take our tool and really get a secure. Oh shoot, it's moving a little bit. Alright, the left wing is a little bit. Alright. Shit. The left wing is a little bit off. Leading edge slat. It's a little bit loose. So let's try and fix that before we seal this off permanently. So across the lower side here. There we go. Lift up that tab. I'm gonna try this again. Let's try this again. Align it. As good as can be. And then tightly wrap it around. Right? Tightly wrap it around. There we go. All right, and then we can finally finish this thing off. Ow, that was my head. All right, half on, half off. Right. Pretty good. Finally finishing off this mechanism. We have the inner edge down. It's pretty secure. I'm just going to use this tool to, it's literally a blunt tweezer, and I'm using the round edge there to make sure the adhesive sticks to the cardstock below. All right, almost there. Now we need the anchor for the elastic bands. Those are gonna be 2 more of these guys right here. So we need to mark out where we want to put it. I'm thinking about adding a spar also, but to be honest, I don't know if I should because it's going to interfere with this straw, so probably not. I'm testing out the wing strength right now. It seems kind of flimsy. We might have to reinforce it. Nope, can't do it from the bottom because that's already the bottom surface. Damn it. All right. I'm not sure. We can do the thing first, you know, the thing, and add a little bit more structural reinforcement next time. But we want to be careful. We don't want a situation like in the back here where we accidentally make a mistake. Accidentally make a mistake. That's so redundant. Anyways, we want to plan forward because if we do this cleverly, we can integrate. I'm thinking about not using necessarily a wooden spar like this, although we absolutely could. I'm not sure it's the best solution. I don't know, but whatever we do, I think we might use like another paper clip here, and we're gonna clip it underneath, right, like that, and then we can make like a frame that holds up this area just to reinforce it a little bit, right? I think that would be pretty neat. And if we could make it one piece, okay, maybe not one piece. I mean, I guess we could. It's just a little annoying to make it one piece. It literally doesn't have to be too complicated. It just goes over the middle, right? Goes through these 2 brass pins, and then forms like a triangle here. just to make this bit a little, make this portion here a little bit more rigid, I think we want to do like maybe a 2/3 from the leading edge type of thing, but we'll see. We can bend the wire back and then make it go like that, or we can separate it into 2 separate loops, right? But the point is, we have to accommodate both this elastic band and a future frame idea here. Well, I guess we'll work off of what we do for the elastic band. The elastic band is more important because we already have structural reinforcement for the wing. It's just a little bit flimsy, right? It's because this part right here is not like really one piece. It's 2 separate pieces. But yeah, we will attach the frame next time. But for now, let's see. This is like the final step before all the moving parts are in place. So let's figure out that. Alright, so I'll move this pin a little bit over. I'm just looking. Doesn't seem to be enough pin on this side, so I'm just shifting this pin over a little bit. We might have to recut another pin that's long enough, but it shouldn't be too long, because otherwise it'll be kind of hard to make it work. All right, so we need the elastic band to come back, and this is gonna be kind of hard. We need it. Oh, yeah. See. God damn it. All right. Let's see right here. This bit right here. All right. I'm trying to keep a solid, healthy tension here. Actually, it doesn't need to go back too much to maintain enough tension. It could literally just be right here, where the circle kind of is tangent to, let's see, if we turn it over, right, if we go like this, just zoom in a little bit so you guys get a better view. If we do this, that's actually already enough tension, so that's actually perfect. And also, if it rests right here in this little corner, where it's tangent to this edge and this structure right here, it's actually reinforcing itself, right? It's not putting all the load onto the material below, but there is some material here that can help it react to this elastic force. So that's pretty good. To do that, I just need to mark out the location where we're gonna place this thing. Approximately right here. I just trace out a contour real quick. I forgot to deploy the lead on this pencil. Damn it. All right, let's do that again. There we go. And then we just need a line there and a line there. And we gotta do the same thing on this side. Oh shoot, I should probably use the other one. There we go. This one is gonna be slightly different because tolerance issues. Right there, right there. You see, like, this is different on each side. So you really have to tailor each part to the side that they belong on. That's why I've been labeling things left and right. Okay. So we're going to puncture these pieces right here. this side. Do that. All right, and then just we have more room here, so we're gonna place the longer tail on this side. Not that it matters that much, but it's just for my peace of mind, right? Everything fits in place. Ooh, this is kind of stiff. All right, there we go. Honestly, you really only need one slot, since I don't even know. Well, one slot for both tails, right? Tails of this brass pin, but having two is forward thinking, because if we do plan on adding a frame reinforcement, you need that gap in the middle, right? So that's kind of the thought process behind that. Okay, so we need to lift this up a little tiny bit. You see that? And then we can wrap this elastic around this brass fastener here. All right, there we go. You see that? It's now a pretension element. Okay, and then we just put it down. And for this one, we can actually go separate ways with the brass fastener. Which is perfect. All right. When you go separate ways, it actually lies flatter against the surface, which is perfect. We're gonna do the same thing for the other side. Make sure that edge doesn't blunt it. All right, I was just adjusting the center pin there for a sec. All right, so long tail in the back, short tail in the front. Oh, all right, it's kind of getting dark in here. Because I'm going late, man. Because freaking YouTube, man. But even if this stream fails, it's not a big deal, because there's really only 2 of you watching this right now. And as long as you know or learn the process, that's good enough for me. In the next stream, I'll definitely have this whole thing to present, which is exciting, because this is a lot of progress done. Everything's coming together very nicely. And then, you just shoot. All right, this might not be enough space here. All right, but that's shoot. All right, we didn't plan this through. We didn't measure enough. Damn it. All right, so it doesn't have to be perfect. This is, I mean, there's a gap on this side too. It's not a perfect assembly. So when you split the tails, it actually applies some tension. So it should be all set. Should be good. There we go. All right. Now, this is almost ready. We just need to do a quick calibration. Just to really smooth out any of the minor issues here. So you'll notice that this leading edge is pointing up by default, which is not right. So we gotta adjust that. The way to do that is just to manually so we can keep it flat and then turn this bit near the end here in so that it hugs that piece better. like that. But I don't think that'll be enough. So might have to apply a little bit more here. Okay, we just need a little tiny bit more. You don't need all that much. It's really difficult to get this thing to work. Okay, we also need a bit more angle adjustment. Like that. Does it rest level? No, but it's still pointing up a little bit. God damn it. Alright. This is the troublesome bit with mechanism is if it's not precise, it's not gonna work perfectly. So you gotta design for these small mistakes and whatnot. Okay, so it's mostly the left side that's lacking a little bit. So let me just adjust this pin. God damn it. This is really frustrating. We are so close. It is literally almost there. To resort to using some tools here. I'm gonna hold this in place. I'm gonna do this on the edge of my table, so you might not be able to see this, but let's see how it is. No, it's still not quite there yet. Need to be a little bit more extreme with this thing, unfortunately. This is when all the manufacturing errors come and bite you back. This is really finicky. Also, I think I might have hurt myself, which is not good. Let me just do this real quick. Come on, man, work with me. Okay, I think this is as good as we can make it for now. I mean, this plane won't be in the default position all the time. So, with that said, I present to you the completed mechanism. Alright, so it might not look like much, but when you do this, hopefully it all works. It deploys the mechanism. Alright, there's a lot of resistance. So let me just make sure that that's good. Alright, so right side is working perfectly if you look at that. If you look at that slat, right? So this rod is pushing forward, and it's working perfectly. But the left side is deciding to be difficult, to say the least. But it does work. It's just it's a little bit finicky. Look at that. Look at that. That is amazing. We have synchronized the tail and slat surfaces. There might be some more calibration needed, but for the most part, this works. I feel like the left side is encountering some issues because there's maybe just not enough space here. Or maybe because there's too much tension. I'm not sure which one's the case here, but when we push forward, oh, it deploys that side. But this side is still needs a little help. I'm not sure why. But I guess we will have to solve that engineering problem next time. Look at that. The slats work. And the elevators, too. It's just very slight right now. Which might be appropriate, to be honest. Look at that. You see that? Slats deployed, right? And slats retracted. You push forward. Oh shit. Alright, you pull back to deploy or to retract, right? Alright, now the right side is having some issues too. Alright, so we need to adjust that. Why is this not? There might be too much friction at the joint. Alright, so look at that. Look at that right there. There seems to be a little bit of wear on this orange piece. Right, there's just too much friction there. So we need to figure out a way to solve that problem, but likely not in today's session. This was supposed to be a 30-minute session, but it ended up being almost 90 minutes. So we're at 84-ish right now. It's gonna be a little shorter again because YouTube was being a dick and it failed. But look at that, the mechanism works. It just it binds a lot. It's not very smooth at the moment. Alright, so if we push forward, it'll eventually, once it get past a certain point where it keeps on getting stuck, it oh shit, I think it bent it a little bit. Damn it. Yeah, that's what happens when you gotta have a mechanism that like has enough give, and I think this mechanism is just a little bit tight. right? So retracting works fine. It's just when you're going forward, both sides want to bind up a little bit. But once it gets past that initial difficulty, it does actually deploy. Right, so now that it's past the neutral point, we can push it a little forward. And you can see the right side is obviously a little bit better at moving, but the left side is just doesn't want to go. Right, it takes a lot of finicking around to get it to work. But when you pull back, it's very obvious both sides need to try and debug that problem next time, in addition to creating a wing frame. But after those two issues are resolved, I mean, the main one being the mechanism not deploying too well, we need to calibrate it and tune it. But it's mostly there. We just need a frame here and then a wing cover, right? Just cover the rest of the wing for example here, right? Like that. And we should be pretty close to completion on this project after that. But like I said, this is probably going to take a while before it's actually complete. So yeah, stay tuned, I guess. This is still very much a work in progress. We might just have to keep the neutral position slats down a little bit so that it doesn't bind. But I'm not sure exactly what the fix for this is yet. Yeah, I'm just checking out the back portion of the mechanism here. Looks good, right? So I've been focusing on the slats mostly, right? But they do deploy. It's just a little bit unresponsive. But the tail also works. If you notice, it's pointing down a little bit, right? And when I pull, it moves in the opposite direction. It's a very, very slight movement here, right? And when I pull, it moves back. So take that as you will, right? Right, look at that. A lot of elevator right there. That's probably like 15, 30 degrees. And when you pull it, it moves back. So the concept works. It's just there's a lot of resistance, and we need to make sure that this thing actually works. So we will be calibrating it and fixing it in the next live stream. That's kind of the plan going forward. Please leave any comments and questions below. I'll try and get to them as soon as I can. But yeah, the concept itself works. It's just, if this mechanism doesn't work out, we still have a great F-16 model, right? It's just, it'll be a huge bummer if it doesn't. But this is, it looks great so far. And I'm excited to debug it in the next session. I'm just gonna bend this down a little bit for now, because the F-16 has a little bit of anhedral on the horizontal tail. But yeah, it works. Would you look at that tail, right? It's okay, so it needs a little bit reinforcement here, but tail, right? It does move. It's just not that much, and to be honest, we don't need that much in flight, right? You only need a little tiny bit. Then the slats, right, once they're unbinded, enables much more movement in the tail. So something's wrong with the slats. That's my point. Look at that. It's super deployed right now. That's not even realistic. But you can tell this mechanism works because when I pull back, both of these surfaces retract. So that's pretty much it for today. It's gonna be a hell of a ride next time trying to debug this thing. But yeah, stay tuned, I guess. Yeah. Thanks for watching. Stay safe, and I'll see you next week.